What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 10, Practice Test. Let's do it. Assume A is opposite A, or alpha is opposite A, beta is opposite B, and gamma is opposite C. Solve the triangle if possible. So here, beta is 68 degrees. B is opposite beta, which is 21. C is opposite gamma, which is 16. So the nice thing here is we have a pair of an angle and its opposite side, which means we can use law of sines. And first I'm going to solve for gamma. So check it out. I'm going to say sine of 68 over its opposite side, 21, equals sine of gamma, which we're solving for, over its opposite side, which is 16. Now we cross multiply to solve. We get 21 sine gamma equals 16 sine 68. Then we're going to divide both sides by 21, right? Boom, boom. And then we want to get rid of the sine, meaning I want to take arc sine of both sides, which would cancel that out. And then we take arc sine of this side here, 16 sine 68 over 21. Let's do that in Desmos. And we get 44.9 rounded to the nearest tenth. Gamma is 44.9 degrees. And then we can use the triangle angle sum theorem, which means these three angles add up to 180. So if that's 68, that's 44.9. That adds up to 112.9. Subtract that from 180 and you get 67.1 degrees. The last thing we need to do is solve for this unknown side, which would be A. And to do that, I'm going to use law of sines one more time. So sine of 67.1 over A, which is what we're solving for, equals, and then I'll use these two because they were given and they're nice whole numbers, sine of 68 over 21. And now let's cross multiply and solve. So we get A sine 68 equals 21 sine of 67.1. Last step, divide both sides by sine of 68. To isolate, and we're going to plug that into Desmos now. And rounded to the nearest tenth, we get 20.9. So the final answer for A is 20.9. So the three missing unknowns were this for A, this angle for gamma, this angle for alpha. Boom, done. A pilot flies in a straight path for 2 hours. He then makes a course correction heading 15 degrees to the right of his original course and then flies 1 hour in the new direction. If he maintains a constant speed of 575 miles per hour, how far is he from his starting position? So I'm going to kind of draw this out like so. So we're kind of going straight for 2 hours and then we do 15 degrees to the right. So kind of like this. And then we do that for another hour. And then we can say if this is my starting point, right? So this is 575 miles per hour. So for 2 hours, he's flown double that, right? Because this is per hour. So in 2 hours, it's 1150 is how far he's gone. And then over here for 1 hour, at that same speed, it's gone 575. And we want to know how far we are from the starting point, meaning that red distance. Now, I can calculate this using the law of cosines. I just need this angle in here. And if I extend this out, right, that's 180 degrees minus that little 15 degree change, right? So 180 minus 15 is 165 degrees, right? So now if this is x, the red side, now I can use law of cosine. So I can say my unknown side x squared equals the other sides squared and added together. So 575 squared plus 1150 squared minus 2 times each of those sides. Hopefully we don't run out of room here. 575 times 1150. Okay, well, and then this times, I'll do it on the next line because I ran out of time, times cosine of the opposite angle, which is 165. Now, I don't want x squared, I want x. So to get the final answer, I need to take the square root of all of this, of both sides. So if I plug this entire equation in, or this expression on the right hand side, into Desmos, we'll get an answer. So let's do that now. And rounded to the nearest whole number would be 1712. So the answer is 1712 miles from the starting position. Boom, done. So for this one, we're converting to rectangular coordinates, and currently this is, right, r theta in polar coordinates. So the way we do that is you remember that x equals r cosine theta and y equals r sine theta. So as we plug and chug, right, this is the r value, that's the theta value. So x is equal to 2 cosine of pi thirds. Y is equal to 2 sine of pi thirds. I could plug this into Desmos, but these are unit circle values. So I know that cosine of pi thirds is 1/2. 1/2 times 2 is 1. So x equals 1. And then sine of pi thirds is the same as rad 3 over 2 times 2 is just rad 3. So y is rad 3. So the final coordinate will be 1, rad 3. Boom, done. So for this one's pretty interesting to convert it to rectangular form because what I first recognized is we got cosecant. And usually we're accustomed to seeing sine or cosine. But the cool thing is if I start by dividing both sides by cosecant like so, right? I get r over cosecant theta equals -3. But 1 over cosecant is the same as sine. So we get r sine theta equals -3. And if we remember our equivalency, r sine theta is equivalent to y. So I just swap that out with y. Now I got my equation in rectangular form. And to get the graph of this, y equals -3 is a horizontal line at -3 for y. So coming across like so, that's the graph. That's how you do it. Done. So for this one, I've made a little table and we're going to plug and chug. And I've chosen these nice values of theta just because they're easy to calculate mentally. But of course, you can choose many, many more and really fill it in if you want to get a more accurate graph. But check this out. This should do the trick nicely. So cosine of theta, or cosine of 0, excuse me, is 1. 1 times 3 is 3 plus 3 is 6. Cosine of 60 is 1/2 times 3 is 1.5 plus 3 is 4.5. Cosine of 90 is 0. 3 times 0 is 0 plus 3 is 3. Cosine of 120 is -1/2. -1/2 times 3 is -1.5 plus 3 is 1.5. Cosine of 180 is -1. -1 times 3 is -3 plus 3 is 0. Then we come to 240. Okay, cosine of 240 is again -1/2. That's going to be just like this value, which is 1.5. Then we got 270. Cosine of 270 is 0. 3 plus 0 is 3. And then we got 300, which is the same as 60, right? That's going to give us 1/2 times 3 is 1.5 plus 3 is 4.5. All right, now let's plot them. So first, starting at 0, we've got a coordinate of 6. Then we got 60 is at 4.5. Then we got 90 is up to 3. 120 is 1.5, right? Radius of 1.5. 180 is 0. 240 is again 1.5, like here. 270 is 3. And then 300 is 4.5. And so you can kind of see in this order, we come around like this and then comes back around like so. That's how you do it. Done. Find the absolute value of the complex number 5 minus 9i. And what we do here is we take the first real component, 5, and we square it. And then we take the coefficient of that imaginary part, which is -9 squared, and we take the square root of the sum. So that's 25 plus 81. And if you add those together, that's 106. Square root of 106 is the absolute value. Done. So to convert this from polar to rectangular, we recognize that r is 5 and theta is 2 pi thirds. And that's pretty cool because x is equal to r cosine theta, y is equal to r sine of theta, all right? So for both of these, r is 5, so 5 cosine of 2 pi thirds. And again, 2 pi thirds, right? It's on the unit circle and it's right around here somewhere, okay? And it's got a reference angle of pi thirds, aka a reference angle of 60, all right? So we can say, you know, cosine of 60 is 1/2, but we're in quadrant 2, so that's -1/2. So this is equal to -1/2 times 5, aka -5 halves for the x component. For the y component, it's 5 sine of 2 pi thirds. And now 2 pi thirds in the second quadrant, sine is positive. And that sine of 2 pi thirds is like sine of pi thirds, which actually is going to give you radical 3 over 2. So 5 times that is 5 rad 3 over 2. That's the y component. So now, to put it in rectangular form, we have the x part as just a standalone constant, and then it's plus 5 rad 3 over 2 times I. And that's how you do it. Done. To give the quotient of these two, the formula is we take the quotient of the r's, r1 over r2, times CIS, and then it's the difference of these two thetas, right? So we'll say theta 1 minus theta 2. Okay, so R1 over R2 is 8 over 2, which is 4. And then we have CIS, and then the difference of 36 and 15 is 21 degrees. And that's pretty much it. That's how you do it. Done. So for this one, the square root of z1, it's also the same as z1 to the 1 over 2. And this is going to equal r to the 1 over n, in this case, which is 1 over 2, times CIS theta over n plus multiples of 2 pi over n, you know, from up to 0 through 2 pi. So we got to see how many of those we can add on, and that'll be the number of answers. So first of all, our r value for z1 is 8. So 8 to the 1/2, that's a square root of 8. And the square root of 8 can be simplified to the square root of 4 times 2. Bring the square root of 4 out as 2. So we have 2 rad 2 CIS, and then we have theta over n, and theta is 36, and then the n in this case is the bottom part here, which is 2. So theta over 2, 36 divided by 2, which is 18. Okay, and then what we're doing is we're at, and I put 2 pi k, but this is in degrees, so that's the same as 360. So multiples of 360 divided by 2, aka add on multiples of 180. And I can only do that once, and then it's going to go beyond 360. So then the second answer is 2 rad 2 CIS, and then 180 plus that is 198. So these are the two answers done. Here we want to eliminate the parameter t, and the way I'm going to do that is first I'm going to isolate t in that first equation. So I'm going to subtract 1 from both sides. Notice I write x of t as just x. That's fine, because this is just saying x as a function of t. So I can say t equals x minus 1, and then I can take this and plug it into t in the second equation. So y equals 2, and instead of t, I'm going to replace it with x minus 1 squared. Now you could FOIL this out and simplify, but they left it as is in the back of the book, so this is the final answer done. So for this one, I'm going to make a little table, and then I'm going to do some plug and chug. And I'm going to choose some values strategically because I know this is sine and cosine. So I want to choose values that are easy to evaluate. So I'm going to choose in degrees. I'm going to choose 0, 90, 180, and 270. So sine of 0 is 0 times negative 2 is 0. Cosine of 0 is 1 times 5 is 5. Then sine of 90 is 1 times negative 2 is negative 2. Cosine of 90 is 0. 0 times 5 is 0. Sine of 180 is 0, so that zeroes out. Cosine of 180 is negative 1 times 5 is negative 5. Last but not least, 270. Sine of 270 is negative 1 times negative 2 is 2. And then cosine of 270 is 0 times 5 is 0. So my points are 0, 5, right? So 0, 5. We got negative 2, 0. We got 0, negative 5. And then we got 2, 0. And now let's connect the dots. And of course, I kind of cheated there, but I did want to draw a nice little perfect ellipse. So anyways, it does come out to be an ellipse. Now we want to turn this into a Cartesian equation. So we need to do a little substitution. But what we notice here, which is amazing, is with the sine and the cosine, we can leverage a Pythagorean identity, which is sine squared plus cosine squared equals 1. So what I'm going to do is for the top one, I'm going to divide by negative 2. So x over negative 2 equals sine t. And for this one, I'm going to divide by 5. Y over 5 equals cosine t. Oops, cosine t, like this. Then I'm going to square both sides. Boom, square both sides. So square, square. And the cool thing about that is now I can say sine squared plus cosine squared is 1. Well, since that's sine squared, that's cosine squared. This plus this is equal to 1. So we can say x squared over 4 plus y squared over 25 equals 1. That's how you do it. Done. So for this one, they give us that u is equal to this and v is equal to this, and we want 2u minus 3v. So we're going to do a little substitution, right? I'm going to plug this in for u, right? Because it was 2 times u, so then I got I minus 3j. And this just ends up becoming like a regular variable expression. And for v, I'm going to plug this in, 2i plus 3j. And then we're going to do a little distribution, 2i minus 6j minus 3, negative 3 times 2 is negative 6i, and then negative 3 times 3 is minus 9j, whoops, like this. And then we're going to add these together. Negative 6 and negative 9 is negative 15j. 2i minus 6i is negative 4i. And there is your final answer. Done. Find a unit vector in the same direction as v. So what we're doing is we're taking 2i plus 3j, and we're getting the equivalent unit vector. And the way we do that is we divide each component by the magnitude of this vector. To get the magnitude, we take this component squared, just the 2 squared, which is 4, plus that squared, which is 9, and we take the square root of that. So 4 plus 9 is 13, so we get rad 13. So I'm going to divide both of these by rad 13 like so, but of course they want to rationalize the denominator in the answer. So we're going to multiply this one by rad 13 over 13. That's going to be 2 rad 13 over, and then rad 13 times itself is just 13, and that's with the I, plus 3 times, we're going to do the same thing here, 3 times rad 13 over, and then again, rad 13 times itself is 13j, and there's the final answer. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.